We are counting down the 10 most insane locomotives ever built on European rails. A parade of overcomplicated, over-engineered, and outright hazardous machines that make sense only if you have never had to clean the oil bath or breathe the exhaust. From experimental steam boxes that slow-roasted their own crews, to trains powered by gyroscopes and spinning propellers at head height, this ranking moves from misguided ambition to sheer mechanical madness. Some tried to solve problems no one had and created disasters only a mechanic could predict. Others look like power plants crashing into airplanes at full tilt. By the time we hit number 1, you will wonder how any of these left the drawing board, let alone the station. Let us kick off the countdown with number 10, a boxy British beast designed to look modern but built to cook its own crew alive. Oliver Bullide wanted to drag British steam into the future. His answer was the Leader, a locomotive that looked like a brick, ran like a steam engine, and felt for the crew like working inside a blast furnace. Built in 1949 and numbered 36,001, it was supposed to be the modern face of Southern Railway. All the moving parts were hidden behind a boxy shell, the valve gear ran in an oil bath, and there was a cab at each end so it never had to turn around. On paper, it was progress. In reality, Bullide boxed in the boiler and the firebox so tightly that heat had nowhere to go. The crew worked next to hot steel, narrow walkways, and steam pipes with barely a breath of fresh air. Union minutes and railway historians all agree, the cab was stifling, the oil fumes were relentless, and every run turned into a slow bake. British Railways scrapped the only running prototype and the unfinished sisters by the early 1950s. Turns out, a diesel-shaped steam oven was a solution to a problem nobody had. Italian engineers in the 1930s looked at a steam engine and decided not to waste a single calorie of heat. They built the Franco-Crosti boiler to squeeze every last bit of warmth out of the exhaust. Efficiency. Instead of a tall chimney sending smoke up and away, these engines ran the exhaust through a side-mounted preheater, then spat the fumes out of low pipes right by the cab. Smoke. On the FS Class 743 in Italy, and later on DB 50.40s and 42.90s in Germany, every shift turned into a lung test. Lung. With the windows closed, the cab turned into a sauna. Crack them open for relief and you got a face full of smoke, soot, and gas. Crews said windows up you bake, windows down you choke. Maintenance crews hated the constant corrosion from soot and condensation in the side ducts. Even with an efficiency gain of about 8 to 12%, most Franco-Crosti engines were yanked from service by the mid-1960s. Efficiency is nice, but not if you have to pick between heat stroke and asphyxiation. Germany's answer to high-speed rail in the late 1940s was to take a record-setting streamliner and flip it around. The 05003 started life as a 464 Pacific, rated for 175 kilometers per hour. It was built to be fast, and the flip was supposed to make it faster. After the war, engineers rebuilt it with the cab at the front. The crew rode ahead of the boiler with nothing but a thin wall between them and the oncoming wind. It gave the driver better sightlines, but it also put people directly in front of all the heat and trouble. The real gamble was the fuel system. Instead of shoveling lump coal, they ground it into a fine powder and blew it down pipes straight to the burners. Pulverized coal burns hot and fast. It is perfect for a stationary power plant, but inside a moving locomotive, it behaves like gunpowder. Every dust-packed pipe was a potential firecracker. When a feed line clogged, the cloud of coal dust could ignite and the whole thing would go off. One clogged line, one spark, and the engine stopped being a train and started being a pipe bomb. Mechanics treated the setup with suspicion. It demanded constant vigilance because physics does not care about optimism. The cab forward promised speed and visibility, but it delivered a maintenance headache and a rolling chemistry experiment. In the end, it was too complex, too risky, and too far ahead of what the shops could reliably keep running. In the 1890s, French engineer Louis-Charles Heilmann looked at the steam locomotive and decided it needed a full electrical overhaul. His answer was the world's first steam-electric hybrid, a literal power plant on wheels. Instead of pistons driving wheels, a vertical steam engine spun a generator, and that generator fed 8 traction motors, 1 motor for each axle. The West 8001 rolled out in 1894, tipping the scales at 124 tons. That is 8 powered axles, each with its own motor and gearbox. On paper, the axle load was just about legal for the best French main lines, roughly 15.5 tons per axle, but the permanent way crews took one look at that rolling substation and watched their maintenance budget evaporate. Every bit of weight hung low in the bogies, unsprung, pounding the rails with every turn. It could haul a 600-ton train at nearly 100 kilometers per hour, but it was overkill for the tracks and depots of its day. Shops were set up to fix simple steam engines, not a moving power station with wires, generators, and more bearings than a factory floor. The concept was decades ahead, steam driving electric motors, but the materials, the infrastructure, and the economics were stuck in the 19th century. Railways passed. No series order, no second act. It was the right idea, just 50 years too early and about 50 tons too heavy for its own good. In 1961, British Rail decided to skip right past diesel and go straight for jet power. The result was the GT3, a locomotive that looked like a steam engine but screamed like a turbine. Under the hood, it packed a 2,750 horsepower gas turbine, the kind of engine you would expect on a fighter jet, not a freight hauler. On the test track, it could hit 90 miles an hour, and it sounded like it was ready for takeoff. Here is the problem. Gas turbines love running flat out at high speed. Stick one on a railway, and you are asking it to idle, crawl, and stop, exactly what turbines hate. The GT3 burned more fuel sitting still than a steam engine did dragging a full load. Every minute at idle was money up the stack. Maintenance was another story. Turbine blades do not like dust, grit, or railway grime, and every overhaul meant bringing in specialists with white gloves and deep pockets. British Rail's accountants took one look at the fuel bills and the shop time and quietly shelved the whole idea. The GT3 was a jet fighter trapped in a tractor's body, loud, expensive, and always thirsty. No surprise it stayed a one-off. In the end, it proved you cannot run a railway on afterburners and wishful thinking. Spain's answer to mountain railroading wasn't more power or heavier steel, it was the Talgo, a train that slithered through curves like a snake made of aluminium. Instead of the usual 2-axle bogies, Talgo cars rode on independent single wheels tucked between each pair of cars. No axles, no rigid frames, just a string of articulated pods, each guided by the car bodies themselves. The ride was smooth, the weight was low, and the train could hug the sharpest bends in the Spanish hills. On paper, it was brilliant. In the real world, it meant you could not just jack up a car and drop out a wheel set. Every maintenance job demanded special jigs, custom tools, and mechanics trained to handle a system that did not exist anywhere else. Maintenance was a full-time job. When Amtrak tried Talgo sets in the US, they had to build bespoke depots just to keep the wheels turning. Even Renfe, the Spanish state railway, kept a fleet of mechanics on call for the variable gauge trickery and the constant attention those independent wheels needed. The Talgo worked, but it worked on its own terms. One, off parts, unique training, and a maintenance bill that made standard bogies look like a bargain. It is not a train, it is a rolling engineering experiment that never quite fit in with the rest of the fleet. Louis Brennan looked at a railway and saw a tightrope waiting to happen. His Gyro-Monorail was first tested in the early 1900s. It wasn't content with 2 rails or even 1 rail and a safety outrigger. Instead, he balanced a 40-foot steel car on a single rail using spinning flywheels hidden in the floor. The secret was gyroscopes, massive iron discs each whirling at thousands of revolutions per minute, fighting gravity every second the train stayed upright. As long as those gyros spun, the car sat perfectly level, even with a dozen passengers swaying inside. But here's the catch: kill the power and those gyros start winding down. When they slow, the balancing act ends. No gentle wobble and no warning. The whole 40-ton car just tips over and buries itself in the dirt. Brennan ran public demonstrations and even invited army officers to ride. The physics impressed everyone until they pictured what happened if the generator failed halfway across a bridge. A regular train loses power and coasts to a stop. A gyro-monorail loses power and becomes a falling piano with everyone inside. The army passed, investors vanished. Brennan's balancing act ended up as a museum piece, remembered for one thing, a train that needed constant energy just to not kill you. In the early 1970s, French engineers looked at the railway and decided wheels were optional. The aero train ran on a concrete beam, floating on a cushion of air, and for good measure, they strapped a jet engine to the roof. The I-80HV prototype clocked 430 km per hour in 1974, faster than anything with steel wheels at the time. It didn't ride, it hovered, screaming past farm fields and villages like a low-flying missile. But here is where physics and politics teamed up for a knockout punch. The aerotrain's turbojet produced a roar measured at 90 to 95 decibels from 60 meters away, louder than a chainsaw, not quite a Boeing 747, but enough to rattle windows and nerves. Every pass sent a shockwave through the countryside. Villages along the Orleans test track filed complaints. Politicians took calls, and the project picked up a reputation for being the loudest thing on rails. On paper, the aerotrain was a technical marvel. In reality, it was a sonic battering ram. The noise wasn't just a nuisance, it was a deal-breaker. By 1974, the French government pulled the plug and threw its weight behind the TGV, quieter, electric, and able to run on steel rails without deafening half the country. The aerotrain proved you could build a hovercraft jet on rails, but good luck getting anyone to live near the track. Sometimes speed isn't the problem, surviving the noise is. George Benny had a vision. Why settle for a slow train stuck behind freight when you could fly commuters above the mess? His answer was the Benny railplane, a propeller-driven car hanging from a steel gantry, running overhead like a roller coaster for grown-ups. In 1929, just outside Glasgow, he built a test track 430 meters long over an active freight line. The car looked like something out of a World's Fair, streamlined and lightweight, pushed along by an aircraft propeller spinning at the nose. The ride was smooth, the view was grand, and the engineering press called it the future of fast travel. But there was a catch. For every mile of railplane, you needed a mile of custom steel latticework, giant gantries straddling the existing tracks, each one more expensive than the last. The car could not carry freight, only a handful of passengers. Every stop meant building a new elevated station, and every curve meant more steel, more money, and more headaches. Investors took one look at the cost estimates and closed their checkbooks. The Great Depression did not help. By the late 1930s, the demonstration track was silent, and the only thing left was a rusting skeleton looming over the fields at Milngavie. The Benny railplane was a marvel of showmanship and a disaster of economics. It solved a problem nobody had, at a price nobody could justify. Instead of changing the world, it became a monument to ambition, outpacing common sense. A roller coaster to bankruptcy, now just a memory in faded photographs and twisted steel. Franz Kruckenberg didn't just want to make a fast train, he wanted the rails to be jealous of the sky. The Schienenzeppelin looked like it had crash-landed from another planet. An aluminum tube perched on two axles, a BMW V12 aircraft engine bolted inside, and at the rear, a two-bladed wooden propeller spinning at head height. No couplers, no extra cars, no apologies. On June 21, 1931, this rolling airship screamed down the Berlin to Hamburg line, hitting 230.2 kilometers per hour, 143 miles an hour, setting a world speed record that steam and diesel wouldn't touch for more than 20 years. But speed wasn't the only thing that made the Schienenzeppelin infamous. The real showstopper was that propeller. 2.8 meters across, spinning at up to 1,500 revolutions per minute, with the blade tips slicing through the air at about 225 meters per second. That was 2/3 the speed of sound, and it wasn't behind a fence or tucked away under a hood. It was right there, at platform level, waiting for someone to forget where they were standing. To call it a spinning wooden meat slicer at head height is not a joke, it is a physics check. If you stood too close, you weren't just risking a bad haircut, you were gambling with your life. The Schienenzeppelin couldn't pull a train, couldn't back up, and couldn't stop in a hurry. Braking was an afterthought, and reversing meant shutting everything down and hoping for the best. It was a one-trick pony, go fast, straight ahead, and pray nothing got in the way. Engineers talked about adding a propeller guard, but any real fix would have turned the whole design into dead weight. By 1939, the dream was over. The engine was stripped out for other projects, and the body was cut up for scrap. No one ever tried to run a passenger service with a high-speed, unguarded propeller again. The Schienenzeppelin was the ultimate in European rail madness, faster than anything on wheels, more dangerous than anything with wings, and absolutely useless for real railroad work. It was the only train in history where the biggest hazard wasn't what was on the track, but what was spinning at the back. Coolest, deadliest, and most impractical, number one with a bullet, or in this case, a flying blade. Across all 10 of these rolling experiments, one pattern stands out. When engineers chase novelty over common sense, the machine becomes a monument to risk instead of progress. These locomotives prove that pushing boundaries is thrilling, but in railroading, complexity often just adds new ways to fail. The lesson? Even in the age of speed and spectacle, sometimes the simplest solution is still the smartest. Which one would you survive? Let us hear it below.